Dear learners, welcome to NIOS Studio. I am Ekta, PGT Chemistry. Today we are going to discuss about lesson 23, Nomenclature and General Principles. You will be able to understand at the end of this unit, you will be able to name the organic compounds by the IUPAC system of nomenclature. Now let us study about the nomenclature of organic compound, which is the most important topic. As parents keep your name, whatever it's Sheila, Rohit, etc. Similarly, organic molecule also has to be named by a certain system which is accepted worldwide, and that system is International Union of Pure and Applied Chemistry, which we call it as an IUPAC system. So let us see how an organic molecule looks like. There is a continuous carbon chain which is in the box, and outside it you will find the pink boxes. There is a functional group OH and Br and another branch in blue color which is CH3. For naming the organic compound, you should know few terms before that, that is homologous series. So what is homologous series? A series of compounds in which the molecular formula of compound differ from those of its next member by CH2 group and molecular mass differs by 14 unit is known as homologous series. Each of such homologous series is given a general name. For example, alkanes, so they have a general formula, like alkanes have general formula CnH2n plus 2, alkenes have CnH2n and alkynes have CnH2n minus 2. Let us see the table. How you call that it is meth? So when there is carbon 1, we call it as a meth, which becomes the root word, and root word is taken as a prefix. So what will be the suffix then? If it is a saturated hydrocarbon, it will be ane. If it is unsaturated containing double bond or triple bond, it will be ene or ine. So when there is one carbon, we call it as a methane. So meth is the root word and ane is the suffix. Root word is taken as a prefix and ane is taken as a suffix. When you have carbon 2, it becomes eth, and if it is saturated, it will have the suffix ane, so it will be ethane. But if it is unsaturated, it will be having ene or ine. For example, when there is carbon 2, so ethene or ethine, the first member of ethene or ethine is C2 carbon because the double bond is present between carbon-carbon. So C double bond C or C triple bond C is ethene or ethine. When you go increase the carbon, like you have 3 carbon, so it becomes prop. If it is saturated, it will be propane. If it has a double bond in any of the carbon, it will be propene. If there is a triple bond, it will be propyne, and so on. So next you can see the homologous series of alkane, alkene and alkyne. CH3, the next homologue is C2H6, next C3H8 and so on. So when you observe this homologous series, you will find there is a difference of CH2 group and the molecular mass differs by 14 units in each case. Let us study about the nomenclature of branched chain hydrocarbons. In straight chain hydrocarbon, branches arises. For example, there is a straight chain and branches like this. So we name it as differently. And how this branches arises, suppose I have a molecule CH3, CH2, CH3, CH3. If I remove one hydrogen from here and introduce another alkyl group, so to produce a branch, I need to remove one hydrogen and that becomes the alkyl group. So the general formula of this will differ by one hydrogen less. So here you will see, so when you remove one hydrogen, it becomes methyl. For example, you have methane, which you can see from the table. When you remove one hydrogen, it becomes methyl. You can see the next, it is ethanes having the formula CH3CH3. When you remove one hydrogen, it becomes CH3CH2, ethyl and so on. let's see about secondary butyl. When you remove one hydrogen from methane, it becomes methyl. For example, CH4 becomes CH3. When you see in ethane, it is CH3, when you remove one hydrogen, it becomes ethyl, and so on. Let's see about secondary butyl, where you are removing one hydrogen from the second carbon. So, it will be secondary butyl. And isobutyl and tertiary butyl, these are conditions of a certain isomer of butane. So, when you remove one, it becomes one hydrogen, it becomes isobutyl or tertiary butyl. Since we are naming the organic compounds, so there are certain set rules to name the branched chain hydrocarbons. So, let us look at that. Rule number 1 says longest chain rule. You need to identify in a molecule the longest chain of carbon, as it is clear from the example CH3, CH2, CH2, CH. At CH you have CH2, CH3 and then CH2, CH3. So, if you count the carbon in a continuous form, so continuous carbon chain is of 6 carbon atoms, so it will be called as hex, and that hex will act as a root word which will be taken as a prefix. So, if it is a particular saturated compound, it will be ane. So, that particular compound is hexane with one branch, which we will be discussing later on. Next, you can see the carbon atoms of the parent chain has to be numbered. So, from which side we should start numbering? So, let us see the example from which side we should start numbering, either from left side or from right side. So, it depends upon the group which is attached to it. So, while numbering the carbon chain, we need to see that the lowest number should be given to the branches also. So, we will start numbering from right side 1, 2, 3, 4, 5 and 6. So, then the name becomes 3-ethyl hexane. 3-ethyl hexane is the name of the given compound. If two equally long chains are possible, the chain with the maximum number of side chains or branches is selected as a main chain. You can see from the example, at second position you have, suppose I take this example CH3, CH, so if I start numbering from right side, I have branch at second carbon, that is CH3, and I have a branch at fourth carbon. So, there are only 2 side chain, but if I number it in different manner, I get 3 side chains. So, when more number of branches are there in a particular compound, you will take that and you will start numbering from that side. So, if suppose I start numbering from here, it is a particular derivative of pentane only, but the branches you will see when I number it differently will be more. So, if I number it from here 1, 2, 3, 4, 5, 6 and so on. So, here I have one branch, here I have another branch and here I have another branch. So, the compound which has maximum number of branches need to be selected while naming the organic molecule. Second rule is lowest number or lowest sum rule. Take an example, if I start numbering from here 1, 2, 3, 4, then my branch will get number 3. But if I start numbering from left hand side, that means if I make it 1, 2, 3, 4, then my branch is at second position. So, this naming is correct. Let us understand the lowest sum rule by taking another example. What do you mean by lowest sum rule? Okay, let us look at this example. If I start numbering from right hand side 1, 2, 3, 4 and 5. When I add the numbers, like my one branch is at second, 4. So if I add it 2 plus 4 plus 4, one branch is at 2 position and 2 branches are at carbon number 4. So when I add it, it comes out to be 10. That means I have to take lowest sum. So if I number it in a different way, that means from left side, then 1, 2, 3, 4 and 5. Now when I add the positions, at carbon 2 I have 2 groups, so 2 plus 2 plus another group is present at 4. So it comes out to be 8. So the naming in this way is correct. Rule number 3. We have to name the organic molecule in alphabetical order. So whosoever comes alphabetically first, we will take that and we will name it. For example, the molecule is here given to you. Now I have one branch at 3. I have group CH2, CH3 and another branch I have here at CH3. So let us satisfy rest of the carbon with hydrogen. You have to keep in mind, you need to keep the valency of carbon as 4. Now, how to name it and how to tell whether it is coming alphabetically ordered or not. So, if you see, this is a ethyl group and here you have a methyl group. So, E comes first, then M. So, we will take ethyl and we will number also from left hand side. So, if I number 1, 2, 3, 4, 5, 6, 7, 8. I could have numbered it from here also, but methyl is coming later in the alphabetical order. So, I prefer it to take ethyl as first. So, then the name of the compound becomes 3, first letter to be capital, 3 ethyl, 6 methyl and then the parent chain is of 8 carbon. So, it will be octane. So, the name of the organic molecule is 3-ethyl 6-methyl octane. Rule number 4 says, if some multiple bonds are present in a chain of carbon atom, then it should be included in a chain. For example, if some multiple bond is present in the chain of carbon atom, it should be included in the chain. For example, you have C, double bond C, single bond C. So, there is no problem because it is a straight chain. But if the chain is like this, so you need to select a chain which has a double bond, leaving rest of the carbon molecule as a substituent or as a branches. Rule number 5, naming the same alkyl groups at different position or more than one alkyl groups. So, if there are same groups present at different position, then you will treat as dimethyl or tri or tetra depending upon how many methyl groups are present in a particular molecule. So, here you can see that there are 2 methyl groups, one is at position 2 and other is at positions 3. So, the name of the compound becomes 2,3 dimethyl pentane. Rule number 6, naming different alkyl substituents. So, when there are different alkyl substituents, you will name it according to the alphabetical order. So, the given compound is having parent chain of 5 carbon and at position number 2 and 3 there are 2 methyl group and at position 3 there is 1 ethyl group. So, the name of the compound is 3-ethyl 2,3 dimethyl pentane. Nomenclature of cyclic hydrocarbons, alicyclic hydrocarbons which I have discussed before also. You have cyclopropane, cyclobutane, cyclopentane, cyclohexane. Cyclopentene, 1-ethyl 2-methyl cyclobutene. So, here are some aromatic compounds. When benzene related compounds, benzene having a chlorine at the side chain, we call it as a chlorobenzene. If bromine is there, bromobenzene. If iodine is there, iodobenzene. If NO2 group is there, it becomes nitrobenzene and ethylbenzene and so on. So, these are called as benzene and its derivatives. Next, there are many more examples like toluene, which is also called as methylbenzene, phenol, hydroxybenzene, aniline, aminobenzene, etc. So, these are some of the aromatic compounds which are accepted IUPAC also. IUPAC nomenclature of aliphatic organic compounds containing functional group. Now, here the catch lies that when they have functional group, then how to name an organic compound. So, there are also certain rules, and rule number 1 says that if there is a functional group, that carbon chain has to be selected. So, let us see, this is my molecule. You need to include that chain which has a functional group, and if there is a carbon in the functional group, then you need to include that carbon in a chain. For example, here you have COOH. So, I will number it 1, 2, 3. Rule 2 says the longest continuous carbon atom chain is numbered from that end which will give the lowest number to the carbon atom bearing the functional group. Rule number 3 says there is a specific suffix for each functional group that replaces the ending E in the name of the corresponding parent alkane. Rule number 4 says if the carbon chain is branched, then the attached alkyl group are named and numbered as in the structure. Rule 1, the main continuous carbon chain of 2 carbon atoms like ethyl group at position 2. For example, here also you have seen CH3CHCOH. So, here it is another branch, same methyl. So, 1, 2, 3. So, the branch gets second position and the functional group here is carboxylic acid. So, it will get position number 1. Rule 5 says while writing the name of the compound, place the substituent in the compound in alphabetical order. For example, if there are ethyl and methyl, then give position according to their ethyl E comes first or M comes first in alphabetical order. Most importantly, you need to remember the order of decreasing priority for the same functional group. Like the first highest priority order is given to carboxylic group COH, then you have sulfonic acid, esters, acyl chlorides, acyl-amides, nitriles, aldehydes, ketones, OH, NH2, C double bond C, ethene and then ethine. For example, you have here the compound CH2, 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 C double bond O, CH3, any compound you take. Now, you notice here that one functional group is this and one functional group is here ketone, which should be numbered first, and how we can name the organic compound when there are two functional groups. So, we need to check the priority order. In priority order, ketones come first, then OH group. So, you will take it as a substituent and the numbering will be, lowest number will be given to the priority functional group. So, 1, 2, 3, 4, 5. Now, I will name it as according to, at 5 position I have OH groups. So, here I have 5 hydroxy. The chain is of pentane, so it becomes pentanone. Let us see the difference. When the lesser priority group is acting as a branch, we will take it as a prefix and the name will end with the main functional group, that is C double bond O, own, not the vice versa. So, here is the list of functional group. At what time you will take prefix or suffix, that depends whether it is acting, whether it is coming in a priority order, according to that you will take. So, here is some common functional group and aliphatic derivatives in a priority order. Thank you.